Okay, we're recording now. Okay, so we're number 5 of ellipses. This word problem here. So a lithotripter uses shock waves to break apart kidney stones or gallstones inside the body. Shock waves generate one focus of the ellipsoid, a three-dimensional shape with an elliptical cross-section. Reflective stone position at the second focus. Write an equation for the cross-section ellipsoid with a dimension shown. How far apart are the foci? Okay. So you want to know how far apart the shock wave generated is from one of the kidney stones, right? And they say that the kidney stone's position at the second focus and shock wave's position at the other focus. Got it. Okay. So what are the dimensions of this ellipse here? Or what are A and B? Just tell me that. Yeah, I'd say A is 14. Now, what do you guys want to make the center, just to make this easy for ourselves?
14.
I'll put the center 0, 0, actually. Right? But you put 14 below, you know, your A squared is 196. You have X squared over 196 plus Y squared is 64 equals 1. Okay. And then how do you solve for C, guys?
Minus B squared.
Easy peasy. That'll be root 132. Right? Did I do that correctly?
Shouldn't it be like
but then it's 2 of them.
Because it's 20. Oh wait, no.
Okay, I'm good. We're good. All right. Can I simplify that fraction? 66. Yeah, 2 root 33. So the distance between the two foci will be 2 times C, or 4 root 33. And that's centimeters, by the way. But that is kind of weird because in real life you don't really express things enough, but you actually give, you know, decimal approximations. So about 22.98 centimeters apart. Okay, we're cool. It's good. Okay.
With this problem, we could put the center anywhere we wanted to.
Totally. But easy to put 0, 0. Okay, we did 6. So let's do 7 and 8. So 7 and 8, once you guys do that in your table groups, I'll come around and make sure you guys are getting it. Then we'll do more practice on the next page. And then we'll close the loop on ellipses, okay? So go and try 7 and 8 in your table groups. 7, you have to complete the square. 8 shouldn't be too hard. It should be pretty straightforward. I'm going to work it out too, see if we get the same answer. All right, so let's work them out.
I don't know how you do this. I have the same thought. I don't know. That would be yeah. I'm sure. Wait, so what did you get outside of the 9? It's 27.
You were 3. About 3 point something. Okay, that's my answer for the first one, guys. See if you guys agree or disagree. Let me know. I could be wrong.
I agree.
Oh,
Yeah, that's not just because I forgot to take it out. What do you think? Wait.
Six is larger than 2.
I'm not good at drawing lips.
Because like 2 times 3 is 6, and 3 is less than
I think that's what I got for number 8. Let me know if you guys agree or disagree.
Oh. Well, I'm so.
right.
You good? Okay. Good. Okay.
Oh, yeah.
Okay. Any questions at all?
Oh.
Okay, I'll give you guys a moment before we move on to the next problem.
I have 2 apart that means speed is 2. No, it's still. I don't even know what I said, but she must have been smart.
No, I was hitting with the pencil. 2.
We're okay. We can move on. All right. We go and okay, guys. Next page. Let's skip 8 and 10 because I think you guys are fine with this. You guys get what's going on here. We'll just do one more with completing the square. Number 9. So let's do number 9 here. So we're gonna skip 8 and 10 on the next page because you guys get the point. You guys know what's going on here. I don't think we need to keep doing more because I really want to move on to hyperbolas today, which is the last type of conic section. Then I hope on Wednesday we'll kind of tie it all together. And then Fridays, let's kind of see how you guys are feeling about this. And then we'll figure out what direction we want to take. Do we want to do a mini test? Do you guys want to do a big test? We'll talk about that by the end of the week. But let's take a look at number 9. Number 9, you have to complete the square, right? So let me at least set this up for you guys. I just want to do one more complete square because that's good practice, right? And then I think we're good. So you can factor out 4, right? You have x squared minus 2x. Nothing to factor out of this y terms. And of course, you put an a on the side. So what I'm going to add inside each set of parentheses. The first set, what do I add?
Oh, what?
1, but you have to put plus 4. Second set, what do I add? So put a plus 4. So you should get 4x minus 1 squared plus y plus 2 squared equals 16. So everything by 16, you get that. Okay, easy enough. Center is at 1, -2. How far to go left and right? 2 left, 2 right. Thank you guys for sharing that. Up and down. 4. 4. Probably should erase some other stuff here. And then I guess could label the coordinates. So I'm just going to do this. Get a little lazy here. You don't have to stay with the R. And the foci would be root 12, or root 12 away from the center. Because c squared is 12, so c is plus or minus 2 root 3. 2 root 3 is roughly 3 point something. And there you go. Okay, we're good? All right. We're going to move on to the next one. Okay, we're good? All right, let's move on. Okay, so we're done talking about ellipses. Let's move on to a new type of shape called hyperbolas. Let me do this with you guys first. Because I don't like how it just kind of just jumps into a problem. I think you guys need a little more, you need to be primed here a little bit. So give me one sec here. Let's do this. Let's share a whiteboard. Okay. That's clear. Okay, so what's the deal with hyperbola? So this is the last type of conic section we'll talk about. We won't get to done today. We'll get as far as we can. So we have a double nap cone. If you were to cut it like that, okay, assume that's how you're cutting it, then what's going to happen is that the cross sections, and that's kind of hard to see, but the cross sections look like something like this. This kind of looks like two parabolas going against each other, so, or going away from each other. So that's what I meant to say. So that's what happens from a geometric or Euclidean perspective. It's going to be a set of all points such that the sum of the distances from two fixed points, sorry, the difference, that's what I'd say, will be a constant. So that means that from, you actually put it in the coordinate plane, let's say you have something like this here. We'll talk about it. Actually, I'll do this. So that's my center. And there's an invisible box in the middle, by the way. I call this the central rectangle. And I'll take a screenshot of this and I'm recording this, by the way, where this distance, okay, this is gonna get ultra busy. Very colorful. That's gonna be called A. And that's called A. this we call B. Gosh darn it. Yeah, let's just keep that there. And that'll be called B. And this is what we call a vertical hyperbola, because it's opening up and down. The center is H comma K, like before. And the two foci are here and here. So if I were to pick a random point, call this D1, and call that D2, then D2 minus D1 will equal a constant. Or the absolute value, because what if D2 is less than D1, right? Or you could do the other way around, D1 minus D2, I don't care. But if you have an absolute value, that guarantees a positive constant, right? So that's what's going on. And then the equation for this would be like this. It'd be x minus h squared over a squared minus y minus k squared over b squared equals 1. Its only difference is that there's a minus and a plus in the middle. And because of the minus, it kind of matters to order which you write it, because this is for a vertical, sorry. I did a vertical one, guys, so let me write it like this. My apologies. But I think you get the idea. So in this case, a squared goes with the positive fraction. If the fraction is positive, that's how it opens. So it's y is a vertical coordinate, it's going to open up and down because that's a positive fraction. It'd be reversed if the other way around. And C, the foci, now it'll be C squared equals A squared plus B squared. Let me take a screen capture of this. There we go. So let's practice this, because I think the more you practice, the more you'll understand what's happening. It's a lot of information I'm throwing you guys away, so I don't expect anyone to absorb it. But Catherine, go ahead, you have a question. It's for vertical. Yeah, because that's what I meant to do initially, but I did the horizontal accidentally. That's for the vertical. The horizontal, you would just do this. Let me tuck it away. Actually, I'll run the board. Horizontal will be this: x minus h squared over a squared minus y minus k squared over b squared. So A may be bigger than B, or might be less than B. We don't know. That doesn't matter. What matters is that A squared goes from a positive fraction. That's what matters. Howdy, go ahead.
Oh, I just want to say that same thing about does it depend on A or B if it's vertical or vertical and horizontal, or if it's like
It's still kind of immaterial compared to ellipses, because whatever is below y is how far you go up and down. Whereas below x is how far you go left and right.
so if you start with x squared, then it's a horizontal.
Totally right. So I think what we should do is we should probably start graphing some of these. Of course, there are vertices too. You have like those are called vertices, which we'll talk about in a little bit. So let's actually try this now. Let's look at the problem so you guys can get the idea what's happening. Yeah, what's up, Duke? Yeah.
How do you know where the like on a vertical things? How do you know where like the
We're gonna get there. We'll get there. I think let's do an example. I think that's gonna make the most sense. So here's the deal. What I'm gonna do is I'm gonna for example 1. Now we've kind of talked about what's happening with hyperbola. Oh, you also have asymptotes too. I forgot to mention that. So there are also asymptotes. Asymptotes are the diagonals of the central rectangle. So the diagonals of the central rectangle. So A is 4 here. And B is 2. Do you guys see why I say, do you guys see why A is 4 and B is 2 from the equation? Yeah, since exactly right. So the center's right here. So the center's easy. That's going to be at what? 1, (-3, right? So then you go to 5, (-3, and -3. So those are your vertices. 5, (-3, and -3, (-3). So that's 4. And that's 4. Now, how far am I going to go up and down from the center? 2 and 2. So then what you do is you draw this. So Duke, does it answer your question? Like, how do we figure out B? Yeah, that's B, and that's A. That's B and that's A. A is not always bigger than B. A could be less than B. A goes with what we call the transverse axis. We call this the transverse. Yeah, the foci is always going to be on the vertices, and the foci are always on the transverse axis. It's basically the axis of symmetry. In some ways, you want to think of it like that. That passes through the middle of the hyperbola. The static stuff hyperbola. Yes, of course, that's an axis of symmetry too. But the transverse axis touches that bit. Thoughts? Yes, exactly. Right. Yeah, so these are your vertices right here. Right. You don't have a covertex necessarily. If you want to say the covertex, you say it's the top if you want to. So yes, in the middle. I don't know. It's, you don't have to say that. The foci. So you're going to do c squared equals a squared now plus b squared. So that's going to be 16 plus 4, 20. So c is plus or minus root 20. Or c is plus or minus 2 root 5. That's what c is. So your foci is going to be 2 root 5 away, which is what? 4 point something. So the foci are actually not too far from the vertex. So the foci are going to be here. Where that's root 20.
So it's the distance away from
The center.
here?
Totally. Correct. Yeah, that's your foci. Okay, I think I know the asymptotes. I do want you guys to state the equation of the asymptotes too. I know you guys are not going to like me for that, but when you do the equation, right? Exactly. Yes. So when you do the equation of asymptotes, use point slope. Let's just be kind of easy here. Use point slope form. X1 and Y1 is going to be center, right? Because you know the center. The diagonal passes through the center, clearly. Both diagonals do. We'll find that in a sec. So I'm going to do x minus 1 and y plus 3. Now the slope. You can just count it. Yeah, totally. So in this case, if you just count it, how far do I rise? How far do I run? I rise how much, guys? 2, and then run 4. So it's 1/2. Or I go down 2 and ride 4. So you're going to say plus or minus 1/2. Yeah, someone said A over B or B over A. It depends on how it's opening. So if it's opening left and right, then it's going to be B over A. That's B and that's A. If it's opening up and down, actually still the same thing, right? Up and down. Actually, the A is going, it's opening this way, right? So you have a central rectangle and you have the diagonals, right? And that'd be A and that'd be B. But you know, who cares about the whole A, B nonsense? Just look at it, right? Go not to right 4, down to right 4, just look at it. And 5.04 makes it much easier for yourself. Okay, so that's like kind of all the parameters, I'd say, of hyperbola. I don't know if there's anything else I need to say about that. Like we wrote the center, we wrote the vertices, we wrote the foci, we wrote the equation asymptotes. So I think we're okay. Yeah. Yes. Good. That's what's happening with the hyperbola. Okay. So actually, I already did part A for us, right? I already found the vertices for us. Part B, I already did that for you guys. I already did part B. I drew the central rectangle. I found the outside. I already did that for you guys for part B. So yeah, I think we. And then now, what if you reverse? What if we reverse these two? I just want to see how far I'd like to get today. I can get pretty far, I think, with this. Okay. So what if we reverse it? Okay. So if we reverse it, now it's going to open up and down.
Great.
Yes, Oliver, go ahead.
This is, so A does not have to be greater.
Right.
B.
Does not have to. Absolutely.
But
Right.
There's like a central ellipse between the parabolas. of
Yes.
A and B.
Well,
So
central rectangle.
central rectangle. But this thing said to draw the related ellipse.
Nah, don't worry about that.
Don't worry about
Yeah. That this is for an algebra 2 class. Kind of, you guys are more advanced with your thinking. Since positive fraction has y, then this opens up and down. Since positive fraction has y in it, opens up and down. What's the center here, guys?
-1.
1, -3, good. 1, -3. Okay, it's going to be opening up and down. How far do you go up and how far do you go down? Yep. Oh, that's the shutters. Okay, let's draw a central rectangle. So the central rectangle is kind of like the foundation of the graph. It's kind of like an ellipse in a way, if you think about it. And I'm going to draw some asymptotes. Okay. So you let the box and you let the asymptotes guide your graph. It's kind of like if you go bowling and they're like contour lanes. If you're really bad at bowling, you're a 6-year-old my son. It's kind of like that. You gotta keep within. But... Okay. You do? Oh, that's bad. Let's get your water polo players. And it's not. I don't think consider bowling a real sport. I mean, there are people who are very talented. I won't discount that. But
What do you think more of a sport, bowling or chess?
put it this way: if you can, I'll just say, if you can drink alcohol and be good at bowling,
Then
it's not a sport. I'm sorry. Chess is totally different. So, yeah. Bowling's more like just don't think. I just go do like playing golf. Just go. Golf is tough too, though. Nothing against golf, but okay. Well, actually, I watched Queen's Gambit. I was really impressed with chess. So anyway, okay. All right, guys, let's get back to this. What else do I need to say here? I think that's it. I think that's all we wanted to do, right? Yeah. We don't need to stay. Don't worry about the foci, and you guys kind of get the idea. But if I were to draw the foci, which would be roughly over here, I mean, maybe I mean I don't know where it's exactly, but if I picked a random point, remember d2 minus d1 will be a constant. That's what we expect for hyperbola. So, okay. You have a question? Go ahead.
How do you know like approximately what the parabola is?
You mean the hyperbola?
Or the hyperbola?
What do you mean, like how the graph looks?
Yeah, I wish the answer knows.
So if, as long as you do the central rectangle, because that should be active. Yeah. And the diagonal should be active also.
Yeah.
And you basically just follow that. You just follow the contours of it, right?
Okay. The difference is a constant, but it's the absolute value of that difference. Because what if you chose a smaller segment minus a bigger segment? That'd be a negative value. So it's got to be absolute. Good.
You know, how, like in ellipse, the constant is like equals like 2n. Is there something that feels constant is going to, or just like?
Actually, good question. I should know this. Wow, Duke, you really ask tough questions. Let me get back to you. I'm not 100% sure. It's a great question, though. Great question. Yeah, Brady? From the center to the foci. Always. Yeah. Yeah, C is always this from center to foci, guys. All right. Let's try. Well, why don't you guys try number 3 on your own? Okay. Try number 3 on your own. See how it goes. All right. We'll check in a couple minutes. Okay. Try that on your own. Scores all, guys.
No, you should just make that. It's just half.
Where did you square root it?
Where are the 4s too?
4 is on the bottom, but it's outside the parentheses of square. It's that.
Guess what I got, guys?
What do you do?
You guys get the same?
Yeah.
Yeah? We're good? Oh, you're right.
Isn't it +3?
You're right. Yep, +3. I accidentally put X minus 3.
It's X minus H.
Okay, cool. Good. All right. Any questions? We're okay? Okay, let's try one more. I won't do 5. I'll save 5 for Wednesday because the rest of these questions are kind of reviewing everything. So it's kind of putting it all together, which I want to save for Wednesday. So let's do 4. Okay. So why don't you guys try this last, and this will be our last problem for today, guys. Okay, so try this last one here. There's some problems involve completing the square. We're not going to do that today. So here.
That's like 60. 75. There's like all of them are not that many.
Tyler, bro. God.
Hey guys, one more. We're almost done here.
We got over 16 minus. What's B? 2 point.
2.5 squared is actually.
Oh, you're sure. This reminds me a little bit of a little bit. It's like not the same. Yeah. Have we not had it?
Wait.
Oh, right. Y'all got this?
Okay, so I got guys. Let me know if you disagree.
Oh, you're right. Thank you. Yes. No, that's right.
No, you're right. You're right. You're right. You're right.
Oh, it's just a quick kind of.
Oh, gosh.
That we did not find.
No worries.
Yeah, you're correct.
Yeah, because that would make sense. The root set is 16 and 6, roots 22, roots 22.
Not a clue. We're doing group 1 and 2.
Okay. So you guys got a lot of the basics, which is good. We'll kind of put everything all together. We'll kind of look at multiple conic sections on the same point, find points of intersection. I'm going to show you some like absolutely crazy type word problems I've done in the past that really blow your mind. We're going to really do some crazy stuff on Wednesday. Friday, we'll continue doing more crazy stuff, and we'll kind of just see how you guys are feeling about this by Friday. Okay. Okay, homework I'm going to assign from the textbook. It's the same packet you guys have. I'll put the page numbers in just a little bit. And then you guys can just do homework. So we're all done. We're all set for today, guys. I'll put up homework right now.